Hi everyone, this is lesson one. So today we're going to be interpreting the structure of expressions, and all that really means is equivalence, or like which of these is the same. So which are the same. All right. So we're going to see some like really high key language here. We can translate it into low key language, and that way we can help figure it out. So select the expression, that means choose one of these, that is equivalent or equal to this thing. So I see a pattern here, or I notice that this is a square, and this is a square as well, and this is subtraction. So I know that this is the difference of squares. So I can go ahead and say, okay, I know this is x and x, 2 and 2, 1 positive, 1 negative, which happens to show up right here with number B, or letter B. That's pretty much it. For this one, they give us pretty much the same direction. Determine whether each expression is equivalent to this one right here. So 8x to the third minus 64. We need to know which of these is equivalent. And you'll notice that there is yes and no. That means we have to select yes or no for every single one. It means we have to compare each and every one. So I don't really know the nifty trick that looks like this when it's x to the third power. That seems hard. I do notice that there's a third power here. I see x and 2x's, that would make x to the third, x and x squared, that would make x to the third. So the things that I know, that doesn't really help me, right? So I'm going to go to my calculator, which as you know on the test is Desmos, so you should open that up on your calculator as well, or on your computer, desmos.com. And I'm going to open it up here. And I'm going to go ahead. I know that if they're the same, they should have the same graph. So let's see if I can get this. Oh, we're frozen. Maybe. See if I can get this over here, maybe. Sorry, y'all. Let me start over. All right, we're back here. And we're going to pull. All right, we're loading Desmos. Here we go. Okay, so sorry about that, y'all. Technical fail. So we're going to take this piece here. We're going to type it right in there. So we see 8x to the power of 3 minus 64. We see this like kind of funky looking line. I don't really know where it goes. It has like a little thing down there. I'm not too worried about the shape of the graph because I'm just looking for the ones that match it. So I'm going to type in the first one, parentheses 2x minus 4, parentheses to the power of 3. And I see that that's a different line, so I know that they're not equivalent because equivalent would mean that they're the same. So I would put an X in the no box. Then I'm going to try the next one. So 8, parentheses, nope, 8 parentheses, X minus 8 to the power of 3. And I see again that the green line and the red line do not match. So I'm going to select no. Then I'm going to go ahead and write my next one, 8x minus 2 and x squared plus 2x plus 4. And I see that the orange line and the red line are exactly the same. I can turn that on and off by clicking the orange button. I see that they're exactly the same, so I know that they are equivalent to each other. I can do the same with my last one, c2x minus 4, 2x minus 4. There we go. And 4x squared plus 8x plus 16. I can see again My purple and red lines are the same. They're the same, so that must mean that they're the same. All right. So that's a quick way to use Desmos on a problem that we don't really know how to solve. We're just trying to find equivalence, so looking for the same graph. Sweet. So let's try this type of problem. Exactly the same structure. It says determine if each equation is true for all values of x. So basically it just means like, is this equation true? So if I look at this one here, I see 2 to the thirds x, 2 to the 3x, and I know that that could be written just like this, which would be 2 to the third, I know is 2 times 2 times 2, which would be 8 to the x. And I ask myself, is that the same as 6 to the x, right? Because that's what they tell me that it's equal to. And of course, I know that those are not always the same. And so I'd say, no, they're not the same. On the other hand, here I have 100x, 100 to the power of x, and I want to know if that's equivalent to 10 to the power of 2x. And I know that 10 to the power of 2 is 100, and so I know that those are equal to each other. I'm going to mark yes. For the third one, I know that e to the power of x times e to the power of x, I see that they have the same base, and I know that I add exponents when I'm multiplying. X plus x would mean that this is e to the power of 2x, which is what they told me it was. I'm going to check yes. And then finally, e to the 2, or 2 to the 10, is equal to 10 to the 2, is what they're telling me. I'm not 100% sure. I can't quite remember my rules here, so I'm going to go back to Desmos. See if I can pull it up on the same screen here. That is being annoying. So I'm gonna try to do it without 2 times 2 times 2 times 2 times 2. That would be 32 times 2 times 2 times 2, 64, 128, 256. I'm just kind of doing that math in my head, but I see that it's 256 at least, and then times 2 again. And this is 10 squared, which is just 100. So I see that those are really different numbers, so I know that they are not the same. All right. This one looks a lot scarier than it is. So it says drag one or more expressions into each box to create an equation that's true for all values of x. So what I know is that in order to add fractions, which I see 3 of, I need to have like terms, right? These are my options. These are the things that I'm going to be able to drag into those boxes. So in order to have like terms, just like if I had 1 over 3 plus 1 over 2, I would multiply this one times that one on top and bottom, and then I'd multiply that one times this one on top and bottom. Right? So we've done that before. So if I want to have the same pieces in each of them, I need to have an x squared, those are connected, and an x plus 2. So in my denominator box, I need to have something that has an x squared, an x, and an x plus 2. And I see that the answer choice that is available is here. So I can drag that right up there. Then I know that I got x plus 2 here, right? But in order to get there, I really needed that x squared. What I do to the bottom, I have to do to the top. So I'm going to have that on bottom and on top. In this one here, I have an x, but I need another x to get to x squared, and then an x plus 2. So that's going to be necessary up here, x times x plus 2. And then on the third one, change colors, this is getting crowded. On the third one here, I have the x squared, I need an x plus 2. So I have x plus 2 on top and on bottom. So when I look here, I see in the first one that it was 3x squared. There already was a 3 there, so I just need to drag the x squared into this box. For the 4 one, the middle one there, I see that it was x and x plus 2 that I needed. So I'm going to take that and drag it into this one. And then finally for that 2, it was 2 times x plus 2. So I'm going to take the x plus 2 and I'm going to drag it into the last one. Right? Not a really beautiful picture here, but essentially we're just making the least common multiple. If you're in honors, you should remember this from last week's honors module. If you are not in honors, it is okay if you skip this problem, right? That's right. All right. For our next example, so select the expression that's equivalent to this thing. So what I'm going to do is I'm going to multiply each of these pieces together. So I have x plus 4 squared, x plus 4 squared, x plus 4, x plus 4, x squared, 4x, 4x, and 16. And then where I'm subtracting this section, taking away x minus 2 times x plus 4. So that means I have x squared plus 4x minus 2x minus 8. So in my first box here, I have x squared plus 8x plus 16. And I'm subtracting the whole x squared plus 2x minus 8. So if I'm thinking about combining my like terms, I'm doing x squared minus x squared. Those things are going to cancel. I am doing 8x minus 2x. That would give me 6x's. And then I'm thinking I have 16 minus negative 8. That's really like plus 8. So that would be plus 24. That's what I'm thinking is my answer. When I look at my answer choices, I'm not convinced that any of those is my answer choice. So I'm going to take a look and see which one would give me the thing that I want. So if I have 4x times 4, that's not going to give me, that's going to give me 4x plus 16. That's not going to be what I want. For this next one, I have 2x plus 1. I will get 2x plus 1 times x plus 4. If I multiply those together, I'm going to get 2x squared. That's not what I have here, so I don't think B is my answer. If I have these ones, I'm going to subtract these. So x minus x, that's going to cancel 4 minus a negative 2. That'd be like 6. I don't think that's the answer either. I'm going to hope this last one is. I have x plus 4 times, and then I have this section here. So I have x minus x, that's nothing. Oops. Those subtract to 0. And then I have 4 minus a negative 2, so that's like a plus sign. 4 plus 2 is 6. So that's times 6 like that. If I distribute these in, I get x times 6, which is 6x. 6 times 4 is 24. That's the same as what I started with. So D is my correct answer. Wow, that was pretty crazy, huh, guys? You're doing a great job. We have 2 more rows. So it says drag a number into each box to create an equation that's true for all values of x. So what I see here is a polynomial on top, which looks like the box, and then a divide by 6 at the end. So I'm going to use this part for the box here. So I have n plus 2, 4n plus 1. That'd be 4n squared, 8n, 1n, and 2. I'm going to combine these here. That gives me 4n squared plus 9n plus